You know that feeling when you look up at the stars or see the perfect spiral in a seashell, and you just sense there's some kind of hidden order to everything? Well, today we're going to decode that order. We're talking about the fundamental language of reality itself, mathematics.
Now, I get it. For a lot of us, the word math just brings back memories of being stuck in a classroom, stressing over problems and formulas we had to memorize. But what if that's not even close to the whole story? What if it's so much more than that?
Because the truth is, mathematics is the very foundation that lets us see and make sense of the universe. It's the silent language that describes literally everything, from the way planets move through space to the beautiful repeating patterns on a sunflower.
And the wildest part of all this? This huge, complex system of logic, this code for the universe, it all grows from the most basic thing we learn as kids. It all starts with the simple act of counting. So yeah, let's start right there, at square one. It all kicks off with that simple human need to just quantify the world around us, to count what we see.
And right after we learn to count, we get our first real toolkit. This is Arithmetic, and it gives us 4 key operations to start working with all those numbers.
First up, you've got addition. This is the most basic tool we have for combining things, for bringing separate groups together into one. Simple, right? And then, of course, you have its opposite, subtraction. This is how we find the difference between numbers, how we figure out what's left when something is taken away. Now, multiplication. This is where things get really powerful. It's basically a shortcut, a way to do addition over and over again really fast. It lets us scale things up in a huge way.
And finally, we have division, which is the inverse of multiplication. This is our tool for breaking things down, for splitting a whole into smaller, equal parts.
Okay, so we have our 4 tools, but you can't just use them in any random order, right? We need a set of rules everyone agrees on. That's the order of operations. You probably learned it as BODMAS or PEMDAS. Think of it like the grammar for math. It makes sure that no matter who's doing the problem, anywhere in the world, we all get to the same answer.
So far, we've just been dealing with numbers we can see and touch. But what happens when you need to find a number that you don't know? Well, that question leads to a massive leap forward into the world of algebra. And this is a total game changer. See, while arithmetic is all about concrete numbers, algebra gives us abstraction. It lets us use symbols, like that famous X, to represent numbers we haven't found yet. This is the moment math stops being a calculator and starts being a detective. And you use this detective work all the time, probably without even realizing it. It's how you figure out the original price of something on sale, or how you can project how much an investment is going to grow. It's all about finding those missing pieces of the puzzle. All right, so from the abstract world of X and Y, let's bring things back down to Earth. Let's talk about the physical world with our next branch of mathematics, geometry. I mean, the name itself is a dead giveaway, right? Geo means Earth, and metron means measurement. So geometry is literally about measuring the Earth. It's how we make sense of all the shapes, sizes, and dimensions of the world we actually live in. What geometry really does is bring order to what can feel like visual chaos. It sorts everything into predictable, measurable shapes, from a simple, strong triangle all the way up to complex polygons. It gives a real, understandable structure to our physical space. But let's be real, the world doesn't just sit still, does it? It's always moving, always changing, and it's full of things you just can't predict. And yeah, you guessed it, math has tools for that too. So, how do you describe a world that's in constant motion? For that, you need a whole new kind of math, and that's where calculus comes in. This isn't about static shapes anymore. This is the math of change, of growth, of movement. It helps us model everything from a car speeding up to how a population grows. And what's so brilliant about calculus is that it gives us 2 powerful and kind of opposite ways to look at change. First, you have derivatives. Think of that like the speedometer in your car. It tells you your speed at one specific single instant. Then you have integrals. That's more like the odometer. It does the opposite. It adds up all those little tiny moments of change to tell you the total distance you've traveled. But what about all this stuff in life that's, well, random, unpredictable? For that, we turn to probability. This is the part of math that actually tries to measure uncertainty. It takes some random event and gives it a clear value, somewhere between 0, meaning it's totally impossible, and 1, meaning it's absolutely going to happen. So think of it this way. If you've got a big container full of different colored bottles, probability is what tells you the exact chance you have of picking a green one instead of a blue one.
It's this incredible tool that turns pure guesswork into calculated risk, and that's what drives everything from weather forecasts to the stock market.
Okay, let's just pause for a second. We've gone from just counting things all the way to calculus and probability. So, what's the big deal? Why does any of this really matter?
Because it's about so much more than just solving for x. Learning this language, it actually changes how you think. It builds up your ability to reason and solve problems. It's the rock-solid foundation for every single piece of modern science and technology. And at the end of the day, it's what gives us the power to look out at this huge, complicated universe and actually begin to understand it.
So if there's one thing to take away from all this, it's that math isn't just some subject in a book. It is the invisible code that writes the story of our reality, from the biggest galaxies to the tiniest grains of sand. So the real question isn't what is math? The question is, what part of your world will you now see is written in its language?